My name's Doug, and today we're going to be talking about extreme performance for latency-critical applications using Oracle TimesTen. We're going to be talking about using SQL data caching your database, also talking about TimesTen in-memory database, and finally, what's new and cool in Oracle TimesTen 22.1. For any database, there tends to be 5 different classes or categories of problems that can make your database go slow. It could be insufficient resources with respect to CPU, memory, or disk I/O bandwidth. You may just have too much concurrent work. Your database may be waiting for storage I/O or network I/O. Or perhaps worse, you may have inefficient SQL optimizer plans. So that's when your SQL gets converted to a plan and it's just not going fast enough. So it turns out that by using SQL data caching, we can help speed up all 5 of those categories or classes. So let's look at those categories one by one. First of all, insufficient resources. If your Oracle database doesn't have enough disk I/O or CPU, by using a SQL data compute nodes, you can get the power of the CPU, RAM, and disk I/O of those compute nodes to offload the work from the Oracle database to help speed up the system. Another scenario is when you have too much concurrent work. So that might be too many users or too many database connections connected to your system of record, usually your Oracle database. Once again, by using 1 or more compute nodes for your SQL data cache, you can use the resources of those compute nodes to speed up your cache, to make those queries, inserts, updates, deletes go faster. One of the most frustrating things with a database is when you're waiting for disk. So whether it's old school spinning disk, SSD, or NVMe storage, it always takes time. So with a disk-based database like the Oracle database, you're forever getting data blocks from the storage system into memory in your SGA to get those data blocks to get the data rows of interest. And when you're committing your transactions, you've got to synchronously write those changes back to storage for the redo and data files. So ultimately, you're going at the performance of your storage. If you want to go faster than that, you can use an in-memory database for your SQL data caching. So what that means is your data is always in RAM. So we're not needing to load data blocks as we go. And when we're committing transactions, we commit them to disk. We will also write those transactions to storage, but we do that asynchronously so you don't have to wait for it. What all this means is you're going at the speed of the CPU and the speed of RAM, not at the speed of your disk. So that will significantly speed things up. You'll also tend to use multiple caches with some form of replication or clustering to avoid a single point of failure. Another annoying thing that can slow you down your database is if you're waiting for network I/O. So what that means is your application is making messages, network calls to and from the database. So you're returning a result set with many rows. All those round trips, all those bytes sent over the wire take time. If you have an in-memory SQL data cache, you can choose to co-locate your applications on the same machine as your in-memory SQL data cache. What that means is all the round trips for that result set occur within memory rather than going across the network. Once again, a whole lot faster. In the situations where you cannot co-locate your application with your in-memory data cache, you can still use PL/SQL stored procedures, just like for an Oracle database, to minimize the number of bytes sent over the wire for round trips. Now, perhaps the the biggest issue which can slow down your database is if you have an inefficient SQL data plan. So for any database, you're fundamentally taking some SQL statement, analyzing it, and figuring out the most efficient way of executing that statement. So we call that a SQL plan. Now, with a disk-based database like Oracle, if you have an inefficient plan, that could result in many reads and writes from your storage device, and you might have to do many network hops. These operations can be quite slow. Now, when we're using an in-memory database, let's look at the worst case. Imagine you also have a bad or inefficient SQL plan in your in-memory database. The worst case is you do more CPU calls and hit RAM more often, because in an in-memory database, you're not accessing the disk, you're not waiting for the disk, you're not waiting for the network. So even an inefficient SQL plan and an in-memory database can be quite fast. Now, just to be clear, I'm not recommending you have inefficient SQL plans. Obviously, you always want to have as efficient plans as possible. So that's normally achieved by having good data models, SQL tuning, having indexes, up-to-date statistics to allow your query optimizer to have the best plan. So always go for the best plan, but even in the worst case, because you're not doing disk I/O or network hops, using an in-memory database tends to make things faster. Now, I've been talking a lot about a SQL data cache. What is a SQL data cache? Well, let's be right up front. A SQL data cache is not a result set cache, because result set caches are dumb. What do I mean by that? A result set cache is fundamentally taking a SQL query, the SQL text, executing it against some relational database like Oracle, capturing the result set, and storing the key and the value, or the query and the result set, in some NoSQL database, be it a key value database or some document store. So the way you use it in practice is if you need to do some query and you can find that query as the key in your cache, you look up the corresponding value as the result set to get the result. So that's kind of dumb, because unless the query is exactly the same, it's not going to work. So it could be something as simple as you have different bind variable values for your query, or you have some extra or different conditions in your where clause. Unless the query exactly matches, it's not going to work in the result set cache. So result set caches are incredibly inflexible and inherently inefficient just because of their design. They're easy to understand and easy to implement, but they're not very efficient. So a SQL data cache is not a result set cache. A SQL data cache is an in-memory database, a SQL relational database. And that database will use the same tables, the same data model, the same columns, the same data types, and the same data as your system of record. So what we're really doing is a one-for-one copy or mapping, and we're just using the SQL relational database, which is our in-memory database, as the cache to make things go faster. So we're going to be using SQL or PL/SQL to do the queries. So we're not doing a dumb result set cache, we're doing an intelligent in-memory relational database using as a SQL data cache. So how do we create one of these SQL data caches? Well, the simplest way of doing it is to let a tool do it for you. In this case, I'm using Oracle SQL Developer and a wizard to create a cache group for you. So we're creating a cache group, but what's a cache group? It's just a bunch of related tables that you want to cache. So you're saying create cache group, and then you're specifying the behaviors for that caching. Do you want to do read-only caching, or do you want to do read-write caching? And do you want to do that synchronously or asynchronously? So through the wizard, you're defining the behaviors of interest. So in the wizard, you're specifying the tables or the objects that you want to cache from your Oracle database. And if there's multiple tables, in this case, we've got two tables, the employee table and the department table. And we've got a hierarchy there because a department can have many employees. So we're using the wizard to specify the attributes of interest. In this case, the primary keys, the foreign keys, we might point to the indexes of interest. So we're capturing metadata from the Oracle database. That metadata is then used to generate these SQL statements. So in this case, we're using the metadata to generate some SQL, which the in-memory database will use to do the caching automatically at runtime. So in this case, it's pretty simple. We've got the departments table from the HR schema. We're specifying the column names, the column types, the primary key, and we're also saying what sort of caching we're doing. In this case, it's going to be read-only caching. But most importantly, we're saying how often we're automatically going to update or synchronize the cache. In this case, it says every 5 minutes, but you're choosing how often to refresh. You might say, no, I actually want to do it every 2 seconds or every 1 millisecond, depending on how frequently you need your cache to be updated. So this is obviously a very simple example, not many columns, one table. In this case, we've got 2 tables, the employee table and the department tables, and more columns. So fundamentally, you're choosing the tables and the columns, and you can even specify rows by adding a where clause of interest. So you're saying what you want cached, and TimesTen will automatically cache that data for you. So when you're caching, you want to do everything. You know, a good cache or an enterprise cache is going to do all the hard work for you. So you don't need to design and maintain custom code. So, you know, the most obvious thing for a cache is it needs to have low latency. Unless it's significantly faster to get the data from the cache, there's no point having a cache. So you always want to have very low latency compared to your system of record. A side effect of having low latency is you tend to get high throughput or more queries per second, which is a good thing. So if you're able to use your cache a lot, that also has a side effect of offloading work from your system of record. So that means your Oracle database is going to do less disk I/O, less CPU utilization, less network messages. It's all a good thing. Now, the hardest thing to do automatically is cache synchronization. Because if you have a cache which is caching old data, stale data, or flat out wrong data, there's no point. Because if you're caching data which is wrong, your cache is lying to you. So that's just the most terrible thing, because you're looking at the wrong information and you don't know it. So keeping the cache automatically updated with the committed inserts, updates, and deletes from your system of record, doing that automatically is the hard thing. So what you really are after is having consistency between the data in your cache and your system of record, and also having consistency of the data within the cache with respect to referential integrity. So you're used to that in your Oracle database. That's the behavior in your SQL data cache. So I'm really talking about minimizing the staleness and making it transparent. If you have a SQL data cache which is using tables and columns and types, just like your Oracle database, that means you can use the same SQL statements, the same PL SQL stored procedures against your cache as with your system of record. So that makes it transparent because you don't need to rewrite your application. If you use a key value or a document store for your cache, by definition, you have to rewrite your application to use the cache. So that's obviously expensive. You also want to be able to have clustering and high availability for your cache. You want to be able to choose whether you can have local or remote positioning for your cache. And obviously you want to have recoverability for your cache. If you lose the power on the machine in your cache, or the entire machine goes down, you don't want to lose the cache. You want to be able to recover the cache, or preferably use one of the other instances of the cache via clustering or replication, such that your cache is always available. So you want to be able to achieve all these attributes as efficiently as possible. So that's easy to say, it's quite hard to do. Now it turns out that TimesTen does all of those things automatically. I showed you how to do that with the wizard in SQL Developer. You're saying what you want, and TimesTen does all this for you automatically. And as a bonus, you could choose to use TimesTen XE. That's the free version of Oracle TimesTen, which also enables all this caching. So you can use the licensed, supported version of TimesTen, or you can use the free, unsupported version of TimesTen called TimesTen X, your choice. So what is this TimesTen thing? Oracle TimesTen in-memory database is a very fast SQL relational database, which comes in two different flavors. There's TimesTen Classic, which is a single instance in-memory database for ultra-low latency applications. Even though it's an in-memory database, we still persist everything to the file system because we don't want to lose anything. So we're writing that data and the redo out to the file system. So it's single instance database, but you'll tend to always use some form of replication to enable high availability. Now, if you want to go really fast, have really high throughput, there's another version of TimesTen called TimesTen Scaleout. So it has all these attributes, but it's a sharded or clustered version of TimesTen. So in this case, we've got 6 shards and 2 copies of each shard. So we've got a single database with many instances, all acting and looking like a single database. So even though it's sharded, your SQL joins just work. You don't have to do anything complicated like a shard key. So it just all works out of the box. And so you've got sharding for scalability and replicas for availability. Single instance database, many instance TimesTen Scaleout, or you can use the single instance TimesTen for small systems. So that's the 2 different flavors of TimesTen, which you can either use as a system of record or as a cache for your Oracle database. So I said that caching needs to be fast. One of the nice things about TimesTen is that it's really fast. So we've got 2 fairly simple SQL statements here. A select statement based on primary key, which takes about 1.7 microseconds to run when using Oracle Cloud using AMD EPYC CPUs. 1.7 microseconds, not milliseconds, microseconds. A microsecond is 1,000 times faster than a millisecond, so that's pretty fast. When you're doing a write, in this case an update, it's taking a bit longer. Why? Because we're doing ACID transactions, so we need to deal with the redo and undo, so we're doing more work, so it takes a bit longer. Still very fast, updates in 3.9 microseconds. Now, if we wanted to use the clustered, sharded, or scale-out version of TimesTen, we can use more nodes to go faster. So in this case, we're doing the same SQL queries, and if we just use 1 shard and 2 copies of each of those shards, we can do about 51 million of those queries per second, which is pretty fast. If we use more shards, in this case 64 shards, with 2 copies of each of those shards for high availability, we can get a net throughput of 3.1 billion SQL queries per second. It's crazy fast. So 64 times 2 is 128. So we're using 128 of these AMD EPYC shapes on Oracle Cloud. So we've got really fast horizontal scaling by scaling out using TimesTen Scaleout. If we wanted to do not a read-only workload, but a read-write workload. In this case, 80% reads and 20% updates. We can do that also with TimesTen scale out. So with 2 nodes here, we're getting just over 5.6 million ACID transactions per second. As we add more nodes, in this case, 64 nodes, we're getting 153 million ACID transactions per second. So just to put that in perspective, most databases struggle to do 1 million ACID transactions per second. So we're doing 153 million pretty fast. So we've talked about using TimesTen for our SQL data cache. So the obvious question is, how good is TimesTen at SQL? Well, it turns out pretty good. So TimesTen supports both Oracle and ANSI SQL. In this first case, we're doing a very simple join between 2 tables, and we're using the Oracle syntax for an outer join. Here it's a different query, but we're using the ANSI SQL syntax, so we're explicitly stating the join condition. In this case, it's a write outer join. So lots of different syntax supported. In this case, we're doing a case statement. You can also do things like cubes, roll-ups, grouping sets. You can even use the SQL with clause to support common table expressions. So lots of fancy SQL to go really fast with Oracle TimesTen used as a SQL data cache to speed up your Oracle database. So we know TimesTen supports SQL and Pure SQL, but how do you use it? You use it the same way as an Oracle database, because we support the same SQL APIs and drivers as the Oracle database. So whether you're using the newer APIs such as Python or Node.js, or old school APIs like ProC and ProCobol, you're using the same APIs and the same SQL drivers as the Oracle database. And you can also choose to use the open source SQL APIs for the Oracle database with TimesTen. It's literally the same code. So I just want to emphasize that TimesTen is a SQL relational database. You've got tables with schemas, columns, data types, constraints, primary keys, foreign keys. It should be very familiar. That's the point. It's supposed to be the same. And once again, you can use tools like SQL Developer so you can see the data, change the data. So if you know how to use tools like SQL Plus or SQL Developer and Oracle, it works just the same in TimesTen. Another thing is you can use GoldenGate to enable caching with TimesTen. So with GoldenGate, you can capture data from various databases, and then you can send it over the network and apply it to databases. So TimesTen can have applied data, so that's captured, inserts, updates, and deletes. So the transactions from these databases can be applied to either TimesTen Classic or TimesTen Scale Out via GoldenGate. Pretty cool. Now let's look at some examples of customers using TimesTen as a cache. So we'll start with eBay. They're a reference customer. eBay's got a lot of customers on a lot of Oracle databases. They've got so many customers, they needed to shard their Oracle database. So even with lots of shards, the number of connections on each large. So they use TimesTen to offload some of that work. So when you use eBay, the first thing you do is you log in and you get your customer profile information. So all of the customer profile information for eBay is cached in TimesTen. So that means you do the queries, the joins against those SQL profiles hitting the TimesTen cache. Because you're hitting the TimesTen cache, it means you don't need a connection to the Oracle database. So there's less connection, less CPU, and less I/O load on the Oracle database, which was a challenge when you have a lot of concurrent users all around the world. So this has been running in production for quite a few years now, and today TimesTen runs in Docker containers managed by Kubernetes for eBay. Another reference customer is T-Mobile. So if you're a T-Mobile customer on T-Mobile.com, your customer account information is stored in Oracle Siebel CRM. So that's a very high functionality system. What T-Mobile was finding was the performance to access that customer information was not as fast as they wanted to be, even with a big, powerful RAC, Real Application Cluster, Oracle database. So what T-Mobile did is they took their existing web services, and instead of connecting to RAC to get that data, they connected to TimesTen cache. So the tables and data of interest use the TimesTen cache, and those same web microservices ran between 5 to 40 times faster out of the TimesTen cache. So they're getting significantly lower latency, faster response time. So obviously it depends on the exact operation, but anywhere between 5 to 40 times faster. So this worked with Oracle CRM. CRM didn't know about this read cache because all the writes, the committed transactions, go directly against CRM, and we're just doing read cache. So it was a transparent cache. So T-Mobile was pretty happy about that. Another customer was using TimesTen scale out with GoldenGate and Oracle. So when you're using GoldenGate, it doesn't matter whether you're using single instance Oracle Real Application Clusters or Exadata, your committed inserts, updates, and deletes get applied to the Oracle database instances. GoldenGate captures them, sends them, and applies them to your TimesTen cache, whether it's single instance or TimesTen scale out. So what this customer did was they applied all their nasty queries against the cache, the clustered version of the cache, which allowed us to process all that in parallel. So why did they do that? They found that based on the customer's benchmarks, they could do very complicated queries 33 times faster than their existing large Real Application Clusters database. So the customer was very happy because they were able to meet the performance objectives using TimesTen scale out with GoldenGate against their existing RAC database. So how can you use TimesTen? Where you can deploy it, on what hardware, and what operating systems? Well, it turns out you can just about deploy it anywhere. So there's lots of operating systems. You can run it on bare metal, on virtual machines, or in Docker containers managed by something like Kubernetes. You have a lot of choices on how and where you deploy it, whether it be on-prem or in your favorite cloud. Next, let's look at what's new and cool in TimesTen 22. The main thing is that TimesTen is now supported on ARM64 for Linux. So what that means is TimesTen can run on something as small as a Raspberry Pi or on enterprise systems such as Ampere Ultra or Graviton. So there's a bunch of other features. It's just more goodness, incremental improvements on what we already have. So we've talked about TimesTen as a SQL data cache to speed up your enterprise applications by using read or write caching either in TimesTen or TimesTen-exe. If you want to find out more about TimesTen, here are the resources. Thank you for your time. Have a good day.